Okay, so here we are in section 2.2, and now we're going to look at trigonometric functions of non-acute angles, angles that are outside of that first quadrant. And so, as we do so, we have a definition of a reference angle. A reference angle for an angle theta, written theta prime, that little hash mark, is the positive acute angle made by the terminal side of the angle and the x-axis. And the reference angle is so important because it's going to allow us to relate every angle back to a first quadrant angle. All we have to do is know what quadrant we're in order to name the sign. So let me show you on these grids. So if we happen to have an acute angle, the reference angle is this angle right here, and it would be the same as the angle theta itself. If theta is in the second quadrant, then theta prime is the notation, is this reference angle right here. And so what you'll find is that if you were to try to find cosine of theta, you could easily just use the reference angle in order to figure out what the ratio is. And then once you know the ratio, you would just determine the right sign. And you'll watch that happen later on in the lecture. The other option is that we could have a third quadrant angle, right? And so again, the big angle here is theta. Well, that's too big for us. We want to relate it back to an acute angle. And so that acute angle is always the angle between the terminal side and the closest x-axis. So this is what theta prime is. And so theta prime is right here. And in this case, theta prime, the reference angle, and theta are the exact same thing. The other option that we have is a fourth quadrant angle, right, where it goes all the way around and ends up in here. Well, if it's a fourth quadrant angle, then pretty obviously the reference angle that we can rely on is theta prime right there. So that's the power of the reference angle. Well, you'll see that power, but first of all, that's what a reference angle is. And so what we're going to find is that, let me just stay right here for a minute and just talk. We will find, let's take a look at this third quadrant angle right here, that sine of theta is equal to, and I'm going to put it in red, it'll be 100% equal to negative the sine of theta prime. Now, why did I put on this negative sign? Well, hopefully you know why. Because all students take calculus, and any first quadrant angle, remember what theta prime is. Theta prime is an acute angle. It's in the first quadrant. This guy right here in parentheses is going to be positive no matter what. But I can't have it be positive. It won't be positive because what I'm really dealing with is a third quadrant angle. And so I got to take it negative. So the reference angle gives me the right ratio to use. And then I have to decide what the appropriate sign is. So if we go and find the reference angle for each one of these down here, the 190 degrees, well, where is 190 degrees? Whoops. 190 degrees is beyond 180 degrees. How far beyond? Well, however far beyond, that's our reference angle, and we're 10 degrees beyond. So the reference angle for 190 degrees is 10 degrees. I can use that to help me out. So I'll never have to memorize anything other than acute trigonometric values on acute angles. 883. This is an example of why degrees are not used very often. It takes a little bit of effort to figure out what this is. I'm going to have to subtract a couple of 360s in order to find out what I have. This would end up at 163 degrees. So where does that? So it's going to end up at the same terminal side as 163 degrees. Well, that's back here in the second quadrant. And how far is that off of that? Well, that looks like it's 17 degrees. So the reference angle for 883 is 17 degrees. Now remember, it went around the circle 2 times fully and then 163 degrees more. 11 pi over 6. Well, let me put that in blue again. Where is that? That's really close to 12 pi over 6. 12 pi over 6 would be 3 pi. So here's, 12 pi over 6 would have been 2 pi. I stated that wrong. So where are we? We're just short of 12 pi over 6. Our So this is the 11 pi over 6. Pretty easy to figure out that we're almost to 2 pi. And then what's the reference angle? That reference angle right here is pi over 6. And so the reference angle associated with 11 pi over 6 is pi over 6. So in order to take the sine of 11 pi over 6, I just have to consider the sine of pi over 6 and what the appropriate sine is for the fourth quadrant. And you'll see that happen right here. Find the exact values of the 6 trigonometric functions for 135 degrees. Okay. Well, where's 135 degrees? Obviously, the second quadrant is beyond 90 degrees, but not quite 180. So the big question is what's the reference angle? The reference angle is 45 degrees, because 45 degrees added to 135 is the 180. So if you're going to find the sine of 135 degrees, it's going to be equal to the sine of 45 degrees, which we know is root 2 over 2, but possibly negative. But let's remind ourselves, all students take calculus, so the sine's going to be positive. Cosine of 135 degrees is going to be the cosine of 45 degrees, which we know is root 2 over 2. And this one's negative because we're dealing with really 135 degrees, which is in the second quadrant. And the tangent of 135 degrees, well, we know what that is. That's going to be negative because we're in the second quadrant, and it's going to have a ratio of 1. And then easy to get the others. Cosecant of 135 degrees is flipping that for positive root 2. Secant of 135 degrees, flip that for negative root 2. And cotangent of 135 degrees is also negative 1. So if you remember at the end of the last video, I was saying that we needed to skip some things. I thought they were a little bit out of place. This one probably should have been 135 degrees, and we just did that. But cosine of 150, wasn't sure why they did that, but let's remind ourselves where 150 is. It's right here, 30 degrees off. So we just have to remind ourselves, what's the cosine of 150 degrees? Well, it's the cosine of 30 degrees. Cosine of 30 degrees is root 3 over 2, and it's in the second quadrant, so it will be negative. And so that's how we get those types of angles coming through. If we were to do something like the tangent of 420, if you think about 420, it's 60 degrees beyond 360, so it's actually a first quadrant angle. Tangent of 60 degrees would be sine divided by cosine. And so the sine of 60 degrees is root 3 over 2. The cosine of 60 degrees is 1/2. Sine divided by cosine, we're going to get a nice root 3 out of that one. Sine of negative 150 degrees. Well, where is that? Third quadrant, right? 150 degrees would be in that third quadrant, backed off of from negative 180 by 30 degrees. And so we just have to ask ourselves, what's the sine of 30 degrees? 1/2. What sign should it be in the third quadrant? Negative. And we're finished. So that's why I skipped those, is because they were kind of premature in where they appeared in these notes. Now, the 3.1 part 2, you can now go do. There's not another lecture that's needed. It's this same type of thing. We just have to ask ourselves, where's negative 5 pi over 6? Well, it's really close to negative 6 pi over 6. It's just backed up by pi over 6. So this is negative 5 pi over 6. So I got a pi over 6 reference angle. So this is equal to, and we're in this third quadrant, so it's going to be negative. And the sine of pi over 6 I have memorized is 1/2. And we're moving on. You should have that memorized. Cosine of 5 pi over 6. Well, that's going this way. And how far? Almost to pi, but we're pi over 6 off again. And so the 5 pi over 6 angle ends up right here. The reference angle is pi over 6. So the cosine of pi over 6 is root 3 over 2. And it's in the second quadrant, so it's going to be negative. And then we have the cotangent of 13 pi over 3. Well, that's really close to and just beyond 12 pi over 3. Well, that's 4 pi. 4 pi would end up right here because this is 0, 2 pi, 4 pi, 6 pi. That's what this line represents, all the even pi's. And so where am I? I'm pi over 3 beyond that. So this is, in the first quadrant, a pi over 3 reference angle. So I have to consider, okay, what's the cotangent of pi over 3? It's cosine divided by sine. The cosine of pi over 3 is 1/2, and the sine is root 3 over 2, so I'm going to end up with the root 3 on the bottom and get root 3 over 3, obviously positive because it's in that first quadrant. They'll have us do a little bit of arithmetic. Sine squared of 45 degrees. Sine of 45 degrees is root 2 over 2. We're going to square that. Plus 3 times the cosine squared of 135 degrees. Well, that's a second quadrant angle, so it's negative. 45 degree reference angle. And so I'm going to get another root 2 over 2. Minus 2 tangent of 225. Well, 225 degrees is in that third quadrant, 45 degrees beyond the 180, and because of that, it's going to have a tangent ratio of 1, and it's actually going to be positive because all students take calculus, and the tangent would be positive there. Root 2 over 2 squared is 1/2, plus 3, oops, I forgot to square that one, times another 1/2, minus 2. And so now we have 1/2 plus 3/2 minus 2, and so we get a nice 0 out of that pretty quickly with our arithmetic skills coming through. So pretty nice. And then evaluate each by first expressing it in terms of its cofunction. I believe that these problems right here illustrate we'll evaluate each function by first expressing that function in terms of an angle between 0 and 360. So this is the downside of degrees, is that you got to subtract away 360. This is going to be equal to the sine of 225 degrees. If you subtract away 360, that's what you're going to get. 225 degrees is a 45 degree reference angle, like we've seen before in the third quadrant. So the answer to this, since all students take calculus, is going to be negative the sine of 45 degrees. That's how we can use our reference angle. So this is negative root 2 over 2. Just to write it out a little bit differently, if I add 360 and add 360 again, I find out that this is the cotangent of negative 210 degrees. And I guess I got to do a little bit more because they want me to express it as an angle between 0 and 360. So let me take the negative 930 and add to that the 720 to get my negative 210. I'm going to add 360 to that, and we're going to get 150 degrees. And that would follow the directions better. So 150 degrees has the same terminal side as negative 930. 150 degrees, where is that? That is in the second quadrant. And where is it? It's 30 degrees back of that. So this is going to be equal to, now all students, cotangent's going to be negative in that regard. I can totally relate it back to the 30 degrees where I have some things memorized. I remember cotangent is cosine divided by sine. So cosine of 30 degrees, root 3 over 2 divided by sine, that's going to leave the root 3 on top. And I'll have just a nice negative root 3, just boxing my answers there. And then example 6. Find all values of theta. So this is getting us used, this is a really good problem because it's going to get us used to solving equations. So find all values theta in the interval 0 to 360 where the sine of theta is equal to negative root 3 over 2. So the first question I want you to ask yourself is, what's the reference angle? So what's the reference angle? What first quadrant angle gives me the sine ratio of root 3 over 2? And hopefully you come up right away that it's 60 degrees through memorization. So I need a 60 degree reference angle. Not everywhere though. Only where the sine is negative. So let's remind ourselves where that is. That's quadrant 3 and quadrant 4. So a 60 degree reference angle in quadrant 3 would be 180 degrees plus 60 degrees for 240 degrees. That's going to be this one right here. 60-degree reference angle right in there. Then the other one is going to be in the fourth quadrant, so that's 360 minus the 60 for 300. So 240 degrees and 300 degrees are our answers. Then we want to go find the exact trig values for these last two right here. That will round up the section. And so what do? First, I would subtract 360 and realize that this is 120 degrees. So then I would say, well, where is 120 degrees? Second quadrant, 60-degree reference angle. Okay, so second quadrant, sine's positive. So this, I don't know why they have all these boxes. I would have said that this is the sine of 60 degrees. This is the, let me take a second off. The only reason I left that sign positive is because it's positive in that quadrant. So my cosine is going to be negative. My tangent's going to be negative. And we're just relating everything back to the first quadrant angle. Why? So we don't have to memorize so much. We're taking advantage of patterns and repetitive cycles that we'll see in other ways. This is going to be the cosecant of 60 degrees and positive, but negative secant 60 degrees and negative cotangent of 60 degrees. So by memorization, what's the sine of 60 degrees? Root 3 over 2. If that's root 3 over 2, then the cosine is 1/2, and it's going to be a negative because it's in that second quadrant. Tangent is going to be sine divided by cosine, which leaves my root 3 on top. And then we're just going to flip everything. And so I'm going to get 2 root 3 over 3. And I'm going to get negative 2. And I'm going to flip that and get negative root 3 over 3. So it's really just those first three that I need to memorize, and then I can just flip the other guys. So negative 390, if I add 360, that's the same as negative 30 degrees. So let's remind ourselves where that is. I'm going in the negative direction, 30 degrees, so I got a 30-degree reference angle in the fourth quadrant. All students take calculus. So what's the sine? The sine's going to be negative the sine of 30 degrees. The cosine is going to be positive cosine of 30 degrees. Why positive? Because we're in the fourth quadrant. Why negative sine? Because we're in the fourth quadrant. Why negative tangent? Because we're in the fourth quadrant. Why negative cosecant? Because we're in the fourth quadrant. Right? That's what's telling us the signs. Secant is related to cosine. Cosine's positive, so secant is going to be positive. And cotangent is going to be negative of what it would be for that first quadrant angle. Sine of 30 degrees by memorization is 1/2, and we're taking the negative of it. Cosine of 30 degrees by memorization is root 3 over 2. Tangent is sine divided by cosine, so the root 3 is on the bottom, so this is the root 3 over 3. And then we're flipping negative 2, 2 root 3 over 3, and negative root 3. And we're finished. That's what you're going to want to get really proficient at. That's the common skill that's there every single time trig is called upon in future classes. The promise that we make you is a majority, if not all, the angles you'll deal with in calculus are these standard ones, and there's no more coming. So you need to know 0 degrees, 30 degrees, right? 45 degrees, if I name them in order, 60 degrees, 90 degrees, 180 degrees, 270 degrees. Why am I not saying things like 120 degrees? Because you're going to see it. It's because 120 degrees can be related to 60 degrees. Why am I not going to say something like 240 or 300? Because you can relate them to 60 degrees. Why am I saying you don't have to memorize 40 or 225 or 210 degrees or 150 degrees? Because through reference angles, they'll come right back to these ones right here that you have memorized. As you do the work in 3.1 part 1, You can just go do that right now. Everything's going to be in terms of radians, which I think is better and will be your most common experience in future classes, not degrees. You'll see them kind of here and there, but majority of the time you will see things written in radians because they're real numbers. All right, good luck in the homework. Let me know what concerns come up.